Welcome to the Terminal Silencers section of the Price training module. The standards and regulations with respect to indoor air quality and ambient sound levels are becoming more stringent all the time. It's imperative for design engineers to have the ability to select and specify products that are assured to meet both criteria effectively. One of the major contributors to noise in an environment can be the terminal unit, the device used to regulate hot and/or cold air to the space. Although silencers and other techniques can be used to decrease this noise, sometimes layout restrictions or other factors will necessitate close coupling of silencers to terminal units. In this unit, we will discuss the problems that can arise when we attempt this, and how we can solve these problems using Price's pre-assembled, pre-tested, close-coupled terminal silencers. In this Price training module, we will explore terminal unit testing and test standards, the challenge of predicting sound levels in close coupling setups, the advantage of combining a terminal and a silencer as one assembly, Price's Quiet Single Duct Terminal Unit, SDVQ, and Price's Quiet Fan Powered Genesis Unit, FDCGQ. What is a terminal unit? The terminal unit controls the amount of air, hot and cold, depending on the unit, that is delivered to a space in response to room temperature. The basic components are a damper, actuator, flow sensor, and related controls. These change with the type of terminal unit being used. There are 6 main types of terminal units. They are single duct, dual duct, induction, bypass, series flow fan powered, and parallel flow fan powered. All of these terminal units are tested in accordance with ARI 880, which is a test standard that is widely used throughout the industry for testing these products. What is a silencer? A silencer is a device that suppresses the noise generated by mechanical systems found in HVAC systems, such as terminal units. An HVAC silencer is similar to a muffler on your car. The car engine's very loud in its raw state. But with the proper application and installation of a muffler, you can reduce that noise to a more acceptable level. It's important to attain proper NC values in areas where you are installing terminal units. If a desired NC level cannot be met with a standard terminal unit, the addition of a silencer can assist in the reduction of the NC rating. The challenge is applying the proper silencer to the proper terminal unit to obtain optimal noise reduction in the desired area. Just like there are different types of mufflers for different types of vehicles, the same applies to selecting the right silencer to fit your terminal unit. Terminal unit testing and test standards. An integral part of the HVAC designer's job is to be able to predict sound levels of terminal units and produce an NC rating acceptable to the project goals. Predictions are often made using data acquired in accordance with the ARI 880 test standard. The ARI 880 test standard allows the manufacturer to gather accurate test data for both discharge and radiated sound levels for a given unit. What is the ARI 880 test standard? The ARI 880 test standard defines how you perform sound power testing on a terminal unit and the requirements for publishing the resulting data. This includes guidelines for physical setup, calibration, isolation, test equipment and methods, as well as rating requirements for units, precision airflow, pressures, and terminal unit settings. Using the methods outlined in the ARI 880 test standard, we determine the sound power levels produced by the terminal unit in 6 different frequency ranges, or octave bands. This is the raw sound that is produced by the unit in the absence of any external influences. The sound power data generated in the test setup is tabulated for the given inlet duct pressure and flow ratings of the terminal unit. In the course of testing the terminal unit, we determine the amount of radiated sound and discharged sound that is produced. For the purposes of this training module, we'll focus on the discharge sound of the terminal units, that is, the sound traveling downstream through the ductwork into the occupied space. NC levels. Another way that the data is provided by the manufacturers is as an NC level for the terminal unit. An NC level is a single number which represents how loud the device will be perceived to be when installed into an environment. It takes into account the human response to different frequencies, as well as the path that the noise takes to get to the observer. The NC level gives designers a good idea of the actual noise level that may be experienced in a room and a basis of comparison between different products. Noise criteria, or NC level values, have become widely accepted as a measure of room noise levels and as a rating scale for equipment that is expected to stay within those levels. ASHRAE has issued recommended space NC values for many commercial air conditioning applications. These standards are used industry-wide. Terminal units should be selected so that the tabulated NC levels are within these designated standards. Since these products can be used in a wide variety of applications, we must make certain assumptions postulating what effects various duct elements, air outlets, and room characteristics will have on the sound performance. ARI 885 describes a set of typical installation conditions and the attenuation effects that each will have on the noise produced by the terminal unit. These adjusted figures provide an estimate of the amount of discharge noise that will be perceived in the room and provides a basis of comparison between different products. You will see these attenuation values or assumptions printed at the bottom of most reputable manufacturers' catalog data sheets and labeled as a sound power deduction. ARI 885 gives attenuation values to allow for the following effects. Environmental effect. A deduction to sound power levels to correct for the difference between free field reference source calibration and reverberant source calibration. Performance data obtained in accordance with ARI 880 are equivalent to free field power levels, but all real occupied spaces behave acoustically more like reverberant rooms. An average-sized room will tend to dampen lower frequencies found in the discharge sound due to cancellation effects. Duct lining. The standard allows for 5 feet of straight duct lined with 1-inch thick insulation. This lined duct will absorb some of the discharge sound as it travels down the duct, so deductions are made to account for this. End reflection. A deduction to sound power levels to correct for the sound that is reflected back into the duct at the point of entering a room. When low-frequency sound waves pass from a small space such as a duct into a large space the size of a room, a certain amount of sound is reflected back into the duct, significantly reducing low-frequency discharge sound. Please note that this assumes a straight run of duct to the outlet. Caution should be taken when conditions are drastically different. Flex duct. The standard allows for 5 feet of 8-inch diameter solid core non-perforated lined flex duct with 1-inch thick insulation. As sound passes through the flex duct, some is absorbed and some transfers through the wall of the duct. Deductions are made to account for this reduction in discharge sound. Space effect. A sound source that terminates in an occupied space is assumed to be a point source, and as you travel away from the point source, the sound will decrease. The size of the room and the distance from the outlet will determine how we will perceive and measure the discharge sound. The standard assumes one outlet in a room with a volume of 2,400 cubic feet and a distance of 5 feet away. Sound power division. At a branch takeoff, acoustic energy is distributed between the branches and/or the main duct in accordance with the ratio of the branch cross-sectional area to the total cross-sectional area of all ducts leaving the takeoff. The standard allows for no branches for small units, 2 equally sized branches for medium units, and 3 equally sized branches for large units. The more branches there are, the lower the discharge sound will be at any single outlet. These attenuation values typically do not apply to any specific project, but have been developed by the industry to provide an easy way of comparing product sound levels between competitors. Application of the various attenuation values in ARI 885, however, should serve only as a guideline in most commercial applications. Now that we know how the NC sound levels are produced based on sound power data and the ARI 885 standard attenuation values, we can now discuss some typical selections and their potential misapplications. The challenge of predicting sound levels. When selecting terminal units based on sound criterion, it's important to understand the way these units are tested and the assumptions the industry has developed to make the products easier to select and specify. This allows us to accurately predict the interaction of the units with the systems in which they are installed. Example 1. Once you've determined the airflow, pressure, and sound requirements for a terminal unit, a selection can be made. For this example, we'll use a single duct terminal unit and a requirement of 1200 to 2100 CFM at 3-inch water gauge and an NC requirement of 35 for standard office spaces provided by ASHRAE. By skimming the terminal's catalog, a selection of a size 12 SDV is within the range of flows and just meeting the NC criterion at its maximum capacity with a discharge NC level of 35. Now we have to remember that these NC levels have been based on the standard deductions provided by ARI 885. If we look at these values in detail, there may be one or more items that do not match the actual system used in this example. Looking at the attenuation values for a large box, we can see that there are several values that are used to generate the NC level of 35 at the maximum CFM capacity of the size 12 unit. If we were to remove one of these values to match our actual job site condition, like the 5 feet of duct lining after the terminal unit, we can see the effect that it'll have on our discharge NC level. So if the project in this example does not include line ductwork, we have accidentally selected a terminal unit that does not meet the noise requirement. Example 2. In this example, we will briefly explain sound power division. You can see that ARI 885 allows for attenuation due to sound power division. You may also notice that the different sizes of terminals have different values for sound power division, ranging from 0 for the small box to 5 for the large box. Here's why. The small terminal unit is assumed to have just enough airflow to be supplying only one outlet. This means that all of the sound power being discharged by the terminal unit is traveling down this one duct and into the room. When we look at the medium box, we can see that an attenuation value of 3 is allowed. This is based on the assumption that we are providing enough air through this terminal that there would likely be 2 outlets in the system, and they are probably providing air to different rooms via 2 equally sized ducts. Therefore, ARI 885 allows for a 3 decibel sound power split. This means that half of the sound energy is going down one duct and the other half is traveling down the other. Furthermore, if we look at the large box, ARI 885 allows for 5 decibels of sound power division. This would lead us to believe that the standard expects that this terminal unit has enough air flowing through it to provide air to several outlets. If we take this into account on our example system, assuming that our terminal unit is only providing one room, look what happens to our NC level. Once again, based on the assumptions provided by ARI 885, we may get ourselves in trouble with what at first looked like a good selection. Example 3. Now let's take a look at another situation, this time for a patient room in a hospital, where there is an NC 35 sound criterion. In this case, we have the same requirements as before, with the added requirement of hospital-grade or fiberglass-free insulation. Typically, we now have to select a configuration that will not introduce fiberglass fibers in the airstream. We will have to eliminate any lined ductwork, and we may choose to go with a fiber-free foam liner in the terminal unit. Although the NC rating for a standard 12-inch SPV at 1200 to 2100 CFM and 3 inches of static pressure meets our noise requirements, our new fiber-free configuration is significantly louder. By changing the terminal liner type and eliminating line ductwork, we have a resultant NC of 41. The deduction for line ductwork found in the ARI 885 deductions is not applicable to our project. While ARI 885 is a good standard for common applications and useful for comparing products, you should be aware of the assumptions involved when designing for specific applications. Terminals and silencers. As noted earlier, an integral part of the HVAC designer's job is to be able to predict sound levels of terminal units and produce an NC rating. Predictions are often made using the terminal unit test data that is obtained in accordance with the ARI 880 test method, incorporating standard ARI 885 duct calculations to get the resultant NC levels. The addition of silencers into the system means that the sound power deductions for silencer insertion loss and sound power additions for silencer generated noise must now be incorporated in order to determine the NC level. Industry standard silencers are tested under ideal conditions with 5 equivalent straight duct diameters upstream and 10 straight duct diameters downstream. This testing procedure does not take into consideration the interaction a silencer has with other duct components. Correction factors for system effects and generated noise have been suggested, but the designers are often not aware of them, nor are these correction factors fully reliable. An alternate method of attaining NC ratings of silencers is to actually set up the terminal unit complete with silencer in an ARI certified reverberation chamber and measure the results. Theoretically, when the calculated and tested values are compared with each other, they should be equal. In actuality, the results can be astoundingly different. More often than not, the performance of a standard terminal unit close coupled to an industry standard silencer does not perform anywhere near what the calculations predicted. In some cases, the terminals tested with silencers directly on the outlet are actually louder than the terminal unit alone. This is caused by the physical relationship of the internal geometry of the silencer and the airflow patterns produced by the terminal unit itself. As you can see, the predicted NC value for the space is NC20 and the actual test result is NC32. These values are considerably different and can adversely affect the engineer's design. We have shown one example here, but after hundreds of tests incorporating standard terminal units and standard catalog silencers, we were able to formulate a definite conclusion. Close coupling of terminal units and standard silencers does not produce predictable results. So how can we ensure that our predictions are accurate to real-world conditions? We'll find out about full terminal unit and silencer assemblies in the upcoming section. Terminal unit assemblies with close-coupled silencers. We have just seen that the close coupling of unmatched products produces adverse system effects, which resulted in inaccurately predicted results, and in some cases sound levels higher than a standard terminal unit without standard silencer treatment. To solve this issue, we must take a new and innovative approach to attaining a quieter unit outside of standard configurations. One such concept is to combine terminals with specifically matched silencers in one integrated and fully tested terminal unit product. By testing the terminal and the silencer together as one assembly in accordance with the ARI 880 standard, variables associated with close coupling products from 2 different manufacturers can be eliminated. The importance of having a fully certified and tested terminal unit silencer assembly for noise-sensitive applications is that design engineers no longer have to calculate insertion loss, generated noise, pressure drop, or even perform a silencer selection to predict sound levels, which in reality may be inaccurate. Furthermore, Price has done extensive testing to develop internal silencer geometries that greatly reduce the noise levels of the terminal units without sacrificing airflow performance or creating more pressure drop within the HVAC system. In other words, engineers will no longer have to allow for silencer pressure drop or self-generated noise within their systems when they want to specify a Price terminal silencer assembly. Price has performed hundreds of tests on a wide range of silencer configurations and developed the quietest silencer terminal unit combinations available from either noise control or air distribution manufacturers. We'll now take a look at some of these Price products. Price Products Overview. Now that we have a better understanding of the importance of terminal silencer assemblies, let's explore some specific samples. Price is pleased to introduce two innovative terminal unit assemblies with close-coupled silencers. They have been carefully engineered, fully tested, and designed for noise-sensitive applications such as classrooms, libraries, performance halls, and studios. They are the ARI 880 Certified Quiet Single Duct Unit, SDVQ, and the ARI 880 Certified Quiet Fan-Powered Genesis Unit, FDCGQ. Some of the benefits that the SDVQ and FDCGQ offer are perfectly mated VAV silencer design for outstanding performance, discharge silencer that reduces or eliminates the requirement for downstream acoustic insulation, test data certified in accordance with ARI 880 certification program, ETL certification according to UL 873 and UL 1995 when high voltage electrical components are required, Price Superior SP300 flow sensor technology, and internal geometries engineered to improve resultant noise levels through our terminal without affecting airflow performance or generating higher pressure drop. In the following section, we'll take a closer look at each of these terminals while examining their features and benefits. Price SDVQ, Quiet Single Duct Terminal Unit. Price's Single Duct Q Series VAV terminals are the HVAC industry's first strategically designed, fully tested, and ARI certified integrated VAV silencer terminal units. This terminal integrates both VAV and silencer technology into one complete package. Extensive lab testing was used to determine the best combination of terminal and silencer configuration, resulting in an assembly which achieves room noise levels of less than NC35 without the addition of downstream acoustic insulation. These fully tested units with optimized geometry have similar pressure drops to that of standard SDV units. This allows the engineer to eliminate allowances for extra silencer pressure drops in the HVAC system. The VAV casing is lined with 1-inch insulation for optimum noise reduction and is designed to ensure an even velocity profile into the silencer section. The casing design and optimized silencer geometry reduce self-generated noise, minimize pressure drop, and maximize acoustic attenuation. The silencer-free area is optimized to match the terminal capacity, and the unit comes with the proven Price damper assembly with accurate SP300 flow sensor. In the past, selection of VAV terminals with silencers has been a complex and risky proposition. The designer had to select the silencer from a variety of available models, free areas and sizes, evaluating silencer attenuation, self-generated noise and pressure drop without really knowing the performance effect of a close-coupled silencer terminal combination. Price eliminates the guesswork by providing an optimized, fully tested, and certified assembly. Price FDCGQ Quiet Fan-Powered Genesis Unit. Price is proud to introduce the Genesis Q Series fan-powered terminals. The FDCGQ is the HVAC industry's first strategically designed, fully tested, and certified quiet fan-powered terminal with custom-designed discharge silencer. While the Price Genesis is the quietest, most durable, easily accessible, and energy-efficient fan-powered terminal on the market, the new Price Genesis Q dramatically reduces discharge sound, eliminating the need for downstream acoustic insulation. The complete VAV terminal silencer assembly has been tested and certified in accordance with ARI Standard 880. The discharge and radiated sound data is presented in Price's catalog and is based on complete assemblies tested in the Price lab. No calculations or system effect assumptions are required to determine silencer performance. Here are some more features and benefits of the Price FDCGQ Quiet Fan-Powered Genesis Unit. Energy-efficient ECM motor. incorporates the innovative design of the Price Genesis with a unique 36-inch long discharge silencer that directly couples to the outlet of the fan. Proven Price damper assembly with accurate SP300 flow sensor. Silencer entry section reduces sound and pressure loss. Silencer design reduces line of sight for increased sound attenuation, and optimized silencer free area is matched to the terminal capacity. Conclusion. We hope that you've enjoyed this look at terminal silencers. You should now have a better understanding of terminal unit testing and test standards, the challenge of predicting sound levels in close coupling setups, the advantage of combining a terminal with a silencer as one assembly, Price's Quiet Single Duct Terminal Unit SDVQ, and Price's Quiet Fan Power Genesis Unit FDCGQ. To learn more about noise control, you can view the Noise Control Fundamentals section of the Price training module. In addition, you can always refer to the Price catalog or visit our website at www.price-hvac.com.